we'll be going to our last question for our class today. Question number 3. In our third question, we are to show from first principle that if y is equal to square root of x, then the differential coefficient of y with respect to x is 1 over 2 square root of x. So this is a proof, okay? If you differentiate square root of x, it is expected that the answer you're going to get will be 1 over 2 root x. 1 over 2 square root of x. We are going to prove this according to the question using first principle. Now the function given to me is y equal to square root of x. Whenever you are given root power function, it's always advisable you change it to fractional index. Root power, you know, where you have all these square roots, cube root, fourth root, change it to fractional index, where you write it as the variable raised to power whatever the root term is. This term you're seeing is the same as x raised to power 1/2, x raised to power 1 over 2. That's the meaning of square root. In square root, there is invisible 2 here. There is invisible 2 behind and inside that square root here, right? If it is cube root, we start showing it. Fourth root, we put 4 there. But square root, we don't show that 2. You need to take note. And this is x raised to power 1. So if I have square root of x, according to indices, law of indices, are you following, right? It's going to be that x raised to power 1 divided by the nth root. In this case, the nth root is 2, like I said, but we don't show it. If it is cube root, then it will be 1 over 3. Are you getting me right? Whatever the power of x is divided by the nth root. So in this case, square root of x is equal to x raised to power 1 over 2. So it means that the function is actually y equal to x to the power of 1/2. So what do we do? Using first principle, let's move on straight. This is y plus delta y equal to, come to this x, add delta x to it, raise everything to power 1/2, 1 over 2. So from here we can now do some expansion while making delta y subject of the formula. So making delta y subject of the formula, it's going to be equal to x plus delta x, then raised to power 1/2 minus 1. And of course delta y will be equal to x plus delta x, and then raised to power 1/2 minus the value of y. The value of y is that same x raised to power 1/2. I should have expanded this since from here, but there's a reason why I don't want to do that yet, because I want to take my time to show you something. Although from our last class I've already tried the much I can to show you how you can carry out expansion of a binomial term using binomial expansion principle. It's not about Pascal's triangle or about let's say a combination. There is a better approach. Okay, there is a better approach that I use. Maybe, like I said in one of our fun classes, I will take my time to show that. But you can still follow as I show you how to carry out the expansion. You know, this is raised to power 1/2, 1 over 2. It is not the type we treated, you know, in our last class, where maybe you have the term raised to power 2, then you multiply it by itself. Let us assume this is x plus delta x raised to power 2. Then you now do x plus delta x in bracket times x plus delta x in bracket. This one now the power is 1 over 2. So we need a better approach to carry out the expansion. So watch as I do that. Delta y will now be equal to, we'll start. The first term, which is x, raised to the highest power given to us here, which is 1 over 2. So we'll have x raised to power 1 over 2. Of course, you know it's going to be multiplied by delta x. But for this first expansion, where the coefficient here is 1, that delta x will carry power 0. Just like saying x raised to power 1/2 times delta x raised to power 0. I said that in our last class, okay? And of course, delta x raised to power 0 will give you 1. So that 1 times this x raised to power 1/2 will give you x raised to power 1/2. Let us move on to the next term. The next term, we need to get a coefficient plus. How do we get a coefficient here? To get this coefficient of the second term, I'm going to use this power 1 over 2 to multiply the coefficient of this first term, which is 1. 1 over 2 times 1 will give me 1 over 2. Then I'll divide it by the number of terms that I have before this next one I want to get. and I have just one term here. So it's going to be 1 over 2 times this one. That's 1 over 2 times 1 divided by 1, which of course will give us 1 over 2 as the coefficient of the second term. Then I will multiply this x by delta x. But you know that when you are multiplying that x by delta x, like I said in our last class, the power of this first term will start decreasing, and then the power of delta x will start what? Increasing. But this is the rule. The two powers must add up to give you the power of the problem you are solving, which is 1 over 2. So in this case, 1 over 2 times x, the power of x will reduce by 1. This is raised to power half. If you reduce half by 1, you get 1 over 2 minus 1. And if you work out this is going to give us minus 1 over 2. So for this power of x to reduce by 1 from here, the new power of x will be minus 1 over 2. Then you multiply it by delta x. That delta x will be raised to power 1 in that second term. Remember here it is power 0, so here it will become power 1. Alright, we'll move on. Plus, we want to get a third term. To get a third term, I will use the power of this x to multiply the coefficient and then divide by the number of terms that I've gotten already, which is 2 terms. So let us go. Minus half times 1 over 2 will give us minus 1 over 4. Minus half times 1 over 2 will give us minus 1 over 4. Now you're going to divide that minus 1 over 4 by the number of terms you have obtained so far. And how many terms have we gotten? 2 terms. Minus 1 over 4 divided by 2 is the same as minus 1 over 4 times 2. This 4 will come down to multiply this 2. So this is actually minus 1 over 8. So minus 1 over 8 is the next term's coefficient, minus 1 over 8. Then multiply the 2 terms you are working on, which is x and delta x. Remembering that the power of x will decrease by 1 and that of delta x will increase by 1. So that becomes x. From here, if you reduce this by 1, what will you get? You get minus 3 over 2. Minus 3 over 2, just to subtract 1 from this. Then delta x will now increase to 2 from power 1 to power 2. Okay, let me do one more. Because we can carry this thing to infinity to keep going. But I'll just do one more. Plus the fourth term. To get a coefficient, I'll use the power of this x to multiply this coefficient. So minus 3 over 2 times minus 1 over 8. What would you get? You would get plus 3 over 16. Then divide it by the number of terms you have already worked on. We have gotten 3 terms here. So if I have minus 1 over 8 times minus 3 over 2, which is equal to 3 over 16. You are going to divide this 3 over 16 by 3 rather. You divide it by the 3 terms. And of course, this is going to give us 3 all over 48. So of course, this fourth term, the coefficient will be 3 over 48. Then what do? Multiply the 2 terms. This will now be x, the power will reduce by 1. If this power reduces by 1, minus 3 over 2, you subtract 1 from it, you get minus 5 over 2. Then times delta x. That delta x will now be raised to power 3. This will continue in that way. Dot, dot, dot. It will continue in that way. If you keep doing it, there will be no point of stopping. So let me stop at this point, put this in brackets, because this continues. But please, come with me. All these things I've been doing is just the expansion of this term. X plus delta x raised to power half. Remember that this whole term is minus x raised to power what? Half. So you write minus x raised to power 1/2. At this point, let us look at what we have. If you open up these brackets, like I said, this thing continues to nowhere, but I have to stop there. This x raised to power half will cancel this minus x raised to power half, they go off. Now, I will divide through by delta x. Dividing through by delta x, I'll have delta y over delta x equal to, are you there? You see, I am done simplifying. And I noticed that some like terms had to cancel out. At every point where you are done simplifying the right hand side, cancel out like terms that have to be cancelled. The next thing you do is to divide through by delta, whatever the independent variable is. In this case, the independent variable is x. So you divide through by delta x. Delta y divided by delta x, that is delta y over delta x, will now be equal to, you come over to this. This is 1 all over 2, x raised to the power minus half, delta x over delta x. Then you come to this term, plus times minus will give us minus 1 over 8, x raised to the power minus 3 over 2, delta x raised to the power 2. Now we are going to divide this by delta x. Then the next term is plus, let me put that here, plus 3 all over 48, x raised to the power minus 5 over 2, delta x raised to the power 3. I'm dividing this by delta x. Remember, there are terms that we have this, this, and this. Divide each of them by delta x. Now this continues. So suppose I decided to get maybe the 5th term, the 6th term, the 7th term. Each of them will be divided by delta x. Let's go and see what we get here. This and this we cancel out. This delta x we cancel this one. This delta x will cancel 1 from here, 2 will be left. This will give us delta y over delta x equal to 1 over 2 x raised to the power minus 1/2, then minus 1 over 8 x raised to the power minus 3 over 2. This term is just waste of time now. I can just cancel this, make them 0, 0, without bothering myself writing them down again. Because you know at this point to get dy dx, you take limit as delta x tends to 0. And if delta x is tending to 0, is approaching 0, this delta x here, you fix 0, everything here becomes 0. Here, fix 0, everything here becomes 0, so you'll be left with just this term. And that will be our answer. Anyway, let me show that. So we have delta x here, and then plus, this term is 3 over 48, x raised to the power minus 5 over 2, delta x raised to the power 2. Let us now take the limits to obtain our dy dx. It implies that dy dx is equal to limit as delta x tends to 0 of all these terms. 1 over 2 times x raised to the power minus 1 over 2, then minus 1 over 8, x raised to the power minus 3 over 2. In fact, I have to fix up my 0 here now. So let me put it 0, and then plus 3 over 48, x raised to the power minus 5 over 2. Then in place of this delta x, you fix your 0 raised to the power 2. And of course, my problem is solved. This whole term will go to 0. This whole term will go to 0 because you are multiplying them by 0. Is that okay? In conclusion, therefore, dy dx is equal to, what is left here? 1 over 2 x raised to the power minus 1 over 2. And from indices, negative index lot of indices, if I have x raised to the power minus a, for example, x raised to the power minus a, it will be equal to 1 over x raised to the power a. So this x raised to the power minus 1 over 2 is simply 1 over x raised to the power 1 over 2. This is equal to 1 over 2 times 1 over x raised to the power half. And of course, from here you know that any term raised to the power half is equal to square root of that term. Concluding, therefore, dy dx is equal to 1 over 2 then times square root of x. And this is our answer, proved. So we've actually shown or proved that if y is equal to square root of x, the differential coefficient of y with respect to x, which is dy dx, is actually 1 over 2 square root of x. So this is the proof from first principle. So we are done with our class today. In our next class, I'll be taking you more into further application of the first principle. This time around, just to show you how the first principle is used to derive all our standard derivatives. For example, if you are given y equal to x raised to power n, dy dx will be n times x raised to power n minus 1. If you are given y to be equal to sine x, dy dx will be equal to cos x. If you are given y to be equal to cos x, dy dx will be equal to minus sine x. If you are given y to be equal to u times v, dy dx will be solved using product rule, which is u dv dx plus v du dx, and also that of the quotient rule. So that is what we are going to be looking at in our next class. How to use the first principle to derive some of these important formulas, standard derivatives.